Welcome to the DIY Honda Garage channel. DTC P2118 indicates a throttle actuator current range or performance problem in the Honda CRV model years 2017 to 2022. The throttle actuator plays a crucial role in managing the air intake of the engine by adjusting the throttle plate's position based on input from the accelerator pedal. It is typically located on the throttle body, found in the intake manifold, just after the air filter. This component interacts with the powertrain control module, PCM, to ensure the engine runs efficiently. When there is a current range or performance issue detected, the DTC triggers, illuminating the check engine light. Comprehensive troubleshooting steps are essential to identify and correct the underlying issues related to this code to restore optimal engine performance. As you proceed with the repairs, reference the specific diagnostic data related to this error code to ensure all potential issues are addressed appropriately. The DTC P2118 alerts technicians to potential problems with the throttle actuator's current range or performance. The throttle actuator is crucial for controlling the air entering the engine and is directly integrated with the throttle body. The throttle body is located in the intake manifold, just after the air filter, where it regulates airflow based on engine requirements. In conjunction with the throttle body, the powertrain control module, PCM, governs the actuator's function, ensuring precise control of the throttle position and, subsequently, the engine's power output. This error can arise when there are discrepancies in the actuator's current readings compared to what the PCM expects. Identifying faults within these components is vital for diagnosing the issue effectively. Therefore, understanding their roles and locations is key to conducting a proper inspection. Several potential causes may lead to the appearance of DTC P2118. Firstly, there may be open circuits in the wiring harness between the throttle body and the PCM, which can disrupt communication and functionality. Secondly, short circuits between the actuator's wires could also manifest, causing erratic performance and incorrect current readings. Notably, issues within the throttle body itself, including mechanical faults or internal circuit failures, can contribute to this error code as well. Each of these issues must be carefully assessed during the troubleshooting process to determine the specific origin of the problem. Proper investigation ensures that all possible failures are considered and rectified effectively, allowing for a comprehensive repair. The symptoms associated with DTC P2118 can significantly affect vehicle operation. One primary symptom is a noticeable drop in engine performance, which may include sluggish acceleration or erratic power delivery, as the throttle actuator struggles to perform as required. Often, this is accompanied by the illumination of the check engine light on the dashboard, indicating a malfunction that needs attention. Drivers might also experience an unresponsive throttle pedal, leading to frustrating and potentially unsafe driving conditions. These symptoms emphasize the need for immediate diagnosis and repair to ensure both vehicle safety and performance are restored as swiftly as possible. Understanding these symptoms will aid technicians in correlating the DTC with actual vehicle behavior during troubleshooting. Step 1 in troubleshooting DTC P2118 requires the technician to turn the vehicle to the on mode, which activates the electrical systems without starting the engine. The next step involves clearing the DTC using the Honda Diagnostic System, HDS, a specialized tool designed for diagnostic procedures in Honda vehicles. Cleaning the DTC resets the system, allowing for a fresh assessment of the vehicle's operational behavior. Following this, the technician needs to slowly press the accelerator pedal to the floor. This action helps check the throttle actuator's response and can reveal immediately if the DTC reappears, indicating a persistent problem. If the DTC P2118 is still present, it confirms that there is a fault that needs to be further investigated. Conversely, if the code does not reappear, it may suggest an intermittent issue that necessitates checking for poor connections or loose terminals. In this step, the technician turns off the vehicle and prepares for continuity testing. The SCS line, or the Service Check Connector, is jumped using the HDS tool. This established connection must be maintained for over 1 minute to ensure accurate readings. Next, the technician will disconnect both the Powertrain Control Module, PCM, Connector B, and the Throttle Body 6P connector to isolate the circuits being tested. The focus shifts to measuring continuity between specific terminals in the Throttle Body connector and the PCM connector. Specifically, the continuity is checked between terminal number 3 of the Throttle Body connector and terminal number 49 of the PCM connector. A positive continuity reading confirms that the SG3 wire connecting these components is intact, allowing the technician to proceed to the next step. On the contrary, if continuity is absent, an open circuit in the SG3 wire must be repaired. During step 3, the technician disconnects PCM connector C to continue diagnosing potential wiring issues. The vehicle should remain in the off position to ensure safety during this testing process. After disconnection, continuity must be checked between terminals of the Throttle Body 6P connector number 1 and number 2. These terminals need to be compared to determine if there is any short circuit present between the MTR1 line and the MTR2 line. Should continuity be confirmed between these test points, it indicates that there is a short circuit, necessitating repairs on the wiring running between the PCM and throttle body. If no continuity is observed, the technician will then proceed to step 4 to continue eliminating possible causes of the error. In step 4, the technician should check continuity between the test points of the MTR1 line and the MTR2 line. This process requires ensuring the vehicle remains off and both PCM connectors B and C are disconnected alongside the throttle body connector. Continuity between the Throttle Body 6P connector terminals, number 1 and number 2, and body ground is verified in this step. If continuity is present, it indicates that either the MTR1 wire or MTR2 wire has a short to ground, necessitating repairs. In contrast, a lack of continuity suggests these wires are intact, and the technician can proceed to the next step to investigate other aspects. This meticulous approach helps pinpoint wiring issues contributing to DTC P2118 and secures an efficient resolution. In Step 5, technicians connect terminals A and B on the Throttle Body 6P connector using a jumper wire to facilitate testing. This allows for continuity checks between the specific terminals of PCM connector C afterwards. The vehicle must remain in the off position during this assessment to ensure safety and accurate readings. When the continuity is checked between terminals C11 and C12 of the PCM connector, it is essential to understand that the intentional jump creates a controlled environment to test the circuit integrity. If continuity is confirmed, that indicates the MTR1 and MTR2 wires are functioning correctly, and the technician can move on to Step 6. Conversely, if continuity is lacking, an open circuit must be repaired between the PCM and throttle body, thus addressing one possible cause of the throttle actuator problem. Step 6 begins with removing the jumper wire that was used in the previous continuity test from the Throttle Body 6P connector. With the jumper wire removed, The technician must measure the resistance between two specific test points at the throttle body side. This test helps to determine if the internal circuit of the throttle body is functioning properly. The ideal resistance range should be between 1.2 ohms and 1 kilo. If the measured resistance falls within this range, the internal circuit is considered healthy, and the technician can then advance to Step 7 for further diagnostics. However, if the resistance measurement is outside this range, the throttle body should be replaced, as this indicates a fault within the throttle body's internal circuitry that needs rectifying to resolve the DTC P2118. In the final troubleshooting step, the technician checks for continuity between the throttle body connector terminals on the throttle body side and the body ground. This test confirms if there is a short to ground issue that may be impacting the throttle actuator's performance. The vehicle must be in the off position and the corresponding connectors disconnected to ensure a safe testing environment. If continuity exists, it proves that there is a short to ground present, and the throttle body must be replaced to rectify this issue. If there is no continuity, indicating that the throttle body internal circuit is functioning correctly, the technician should reference any authorized service information or troubleshooting guidelines associated with DTC P2118 for further assistance. This structured approach ensures all potential variables are addressed thoroughly. After completing the necessary repairs indicated by the troubleshooting steps for DTC P2118, it is crucial to verify that the problem has been fully resolved. The first step in this verification process is to clear the DTC using the Honda Diagnostics System, HDS, to reset the vehicle's monitoring systems. Following this, the technician should perform a detailed check to confirm that there are no lingering issues associated with the throttle actuator. A test drive is also a vital component of the verification phase, allowing the technician to experience vehicle performance firsthand. During this drive, any hesitation, abnormal behavior, or warning lights should be monitored closely. If no further concerns arise, it confirms the previous repairs were effective, enhancing the vehicle's reliability and ensuring it operates safely and efficiently on the road. To help prevent future occurrences of DTC P2118, implementing a routine preventive maintenance schedule is essential. Regularly checking the wiring harness and connectors linked to the throttle actuator and PCM can identify potential issues before they escalate into significant problems. Inspecting the throttle body for dirt, debris, or mechanical wear every few months will help ensure optimum performance. Ensuring your software for the Powertrain Control Module PCM is always updated with the latest manufacturer recommendations will maintain communication efficiency between all electronic systems. Educating vehicle owners about proper maintenance practices can assist in minimizing wear and tear on these components, promoting vehicle longevity and performance. Keeping track of these aspects enhances the overall health of the engine and the vehicle's drivability. In conclusion, understanding DTC P2118, which signifies a throttle actuator current range or performance problem, is crucial for effective vehicle upkeep. Following a structured troubleshooting approach allows technicians to systematically diagnose and rectify issues surrounding the throttle actuator and its communication with the PCM. The importance of continuity checks and resistance measurements cannot be understated, as they are vital indicators of electrical and component integrity. After repairs, ensuring final verification through test drives and clearances of DTCs guarantees that the vehicle operates as intended. Practicing preventive maintenance will help mitigate future concerns by keeping the wiring, throttle body, and control module in optimal condition. This comprehensive understanding fosters a safer and more reliable driving experience for Honda CRV owners. Please like and subscribe to the channel. See you next time.